Hey guys, welcome to 6.4 video notes where we're going to be looking at different representations of a proportional relationship. So we're going to start with the verbal description, and then we're going to see the equation, and then how can we transfer that information into a table and then a graph. So here we go. The student council is selling t-shirts to raise awareness for the local animal shelter. For each t-shirt they sell, they will donate $5. So we need to write an equation to represent this relationship using y equals kx. We need to find our k value. Our k value is going to figure out, we need to know how much is donated for one t-shirt. So dollars donated per shirt is our k value. And do we have the information? Yes, we do. Our k value would be 5. They're donating $5 for one shirt. So our equation would be y equals 5x. So now we're going to use this equation to fill out the table. So our table, number of shirts sold, we have these values. We need to know how much is going to be donated for these given amount of shirts. Well, if we look at our equation, 5 times 0 is 0. So if they sell 0 shirts, they will donate $0. What about 10 shirts? 5 times 10 is 50. 20 times 5 is 100. 30 times 5 is 150. 40 times 5 is 200. 50 times 5 is 250, and 60 times 5 is 300. All right, so now we need to label our axes. Of course, that's my y-axis, and this is my x-axis. We need to label our axes with our variables. We have numbers of shirts sold and dollars donated. Go ahead and label your axes. All right, there's your axes labeled. Dollars donated. Money is always going to be your y, and then x is number of shirts sold. Okay, so now we need to plot these points. I want you to go ahead and plot these points on your graph. All right, that's what your graph should kind of look like. The 60, 300 kind of goes off the page. We can kind of estimate where that would go. So there's your graph. So let's scroll down to the questions about the graph table and equation that we just talked about. Number 1, describe how you know that the above situation is proportional. How do we know that this is proportional? Look at the graph. What do we know about the graph? In 6.3, we learned there's 3 things we need in order for a relationship to be proportional in terms of a graph. Number 1, goes through origin, or 0, 0. Number 2, is it a straight line? Yes, it's a straight diagonal line. And what else do we know? It has a k value. Y over x is equal to 5, or otherwise known as k equals 5. So there's a constant of proportionality for all of my values on my table and in my graph. So those are 3 things that I know that makes this proportional. We already found our k value. Our k value is y over x, which we found in our equation up here for the t-shirts. Now we can solve it from the graph. So I'm going to pick a point on the graph. I'm going to pick here, 10, 50. That's the point I'm going to use from the graph. 10 over 50. 50 divided by 10 is 5. So k equals 5. Now 3, what does the rate of change represent in this situation? What does the k value mean? I want you to brainstorm. What do you think k equals 5 means in this problem? We kind of talked about number 3 in the beginning of the problem. We know that this k value represents that for every one shirt, $5 will be donated. So sorry, up here, change this to a $5 donated, not dollars donated. There you go. $5 donated per one shirt. So for every one shirt sold, $5 will be donated. That's what the k value represents in this situation. Let's look at number 4. What does the ordered pair 10, 50 mean in this problem? So look at the coordinate point, 10, 50. What does that mean in terms of your variables? Go ahead and answer numbers 4. And look at number 5. If the student council sells 80 shirts, how much will they donate to the animal shelter? So if 80 shirts are sold, how much will be donated, do you think? Go ahead and try those 2. All right, number 4. So you should have noticed that 10 is my X, so it's 10 shirts. So if 10 shirts are sold, that means $50 will be donated. This is another way to look at the problem. If you have 10, 50 in this problem, it's really just 10 shirts, $50 donated when you think about the variables in our problem. Number 5, we can use our equation that we wrote, y equals 5x, to solve for this problem. We need to know my y value. How much money will be donated? So we can multiply 5, the cost the amount of donations for one shirt times the amount of shirts we have, which is 80, and you get $400. All right, turn your page over. All right, we need to write the verbal description for this equation. We're given y equals 3x. Try to come up with your own situation where you'd be multiplying by 3 each time. I'm going to give you a second to do that, and then I'm going to tell you an example that I used. Okay, so if you want me to check which one you use, that's great. But we also need to make sure you use the same one that I did because the table is going to match our verbal description. So if you made your own up, come ask me if it's right. But other than that, please make sure you also write mine so you can use this in the problem. So Jack can paint 3 pumpkins each hour because I know it has to be that because it says number of pumpkins painted on my y-axis and hours on my x-axis. So our equation then would be y equals 3x. Now go ahead and fill in this table. For each amount of hours, how many pumpkins can Jack paint? Here's your table. So for every hour, you're adding 3 each time, right? So it's 3, 6, 9, 12, 15, 18, 21. And then now you need to plot these points on your table, on your graph, excuse me. All right, here's your graph. Notice I did put a 0.800 because if Jack spends 0 hours painting pumpkins, how many can he paint? 0. So that's going to go to my origin. So that's what your graph should look like. All right, we don't have any questions to answer about it. So now we have our last example. We don't have the verbal, we don't have the equation. We have our variables. We have miles traveled and hours for Jaguar's daily movement. And we have a missing values in our table. I'm telling you that it's proportional. So how can we find these missing values? I'm going to give you an example of how we can do that. We need to find our K value. What's our K value? You should think to divide y over x. So let's do 18 over 12. I knew miles was my y because look, y is over here, which is my miles traveled, and x is my hours. So 18 over 12, you get 1.5. So my K value is 1.5. So how can I use that to fill in these missing values? Write your equation. Y equals 1.5x. That means my y value is equal to 1.5 times my x values. Hours is my x values. So multiply all your x values by 1.5, and that'll give you your y values. So go ahead and multiply all of your x values by 1.5, and then come back to me. All right, here is your missing values filled in. Now we need to write our verbal description in our equation. So K value is 1.5. So an example of the verbal would be a jaguar travels 1.5 miles per hour. Because that's my y variable, that's my x variable. Our equation, we already solved for it. It's 1.5x. Or we could have used different variables. We could have said, maybe we were talking about distance. Maybe we say d is y for distance. Distance equals 1.5 times t for time. So you could have done either one of these. You can use different variables instead of just x and y. Okay, I'm going to give you a second to plot your graph, and then we are done. All right, there's your graph. Remember, 0 miles, 0 hours will be 0 miles for Jaguar's movement, so that's why it's at the origin. All right, guys, so that's all 6.4 has to offer. So remember, verbal description, equation, table, and graph should all be similar, and you can use them to solve for one another. Go complete your must-do and ace that mastery check.